Welcome to part 4 of this video series on the unit circle and trig functions. In the last video, we completed this table with all 6 trig functions in the first quadrant at these key angles, pi over 6, pi over 4, pi over 3, as well as 0 and pi over 2. So now that we have these under our belts, in this video, we are going to discuss how we can use something called reference angles to extend that knowledge to the entire unit circle, right? Before we were just working up here in quadrant 1. Now I want to talk about how we can use that to figure out what's going on here, here, and here. So basically, I want to explain this just through 3 examples, and hopefully those will help you see how we can do this in general. So let's start with this sine of 7 pi over 6. How would I go about evaluating this? Well, here's the key observation, the key fact, okay? This guy is written as, it's a pi over 6, right? It's 7, maybe key facts in there, maybe key observation. Because of the pi over 6 in the denominator, I know that sine of 7 pi over 6 is going to be equal to plus or minus sine of pi over 6. In other words, it's going to be basically the same, except there could be a negative sign thrown in there. That's how it works with all of these reference angles, where you look at the denominator, right? So in this case, it's a pi over 6. Okay. This is a pi over 6, so that tells me that I'm going to be using the sine of pi over 6 value. Okay. And this pi over 6, this is what we call a reference angle, which is hence the name of the video and the name of this topic in general. Okay, this is called a reference angle. If I know sine of pi over 6, I can then use that to figure out sine of 7 pi over 6. Right? We know now that sine of pi over 6 is a half. So I know that sine of 7 pi over 6 is either going to be positive 1/2 or negative 1/2. Okay, similarly, let's just say that we were given cosine of 9 pi over 4, say. That would be plus or minus cosine of just regular pi over 4 because of that over 4 down here. These are both over 4s. Now, you do have to be a little bit careful with this. For example, if you were given sine of 8 pi over 6, right, your instinct might be, oh, so then we're going to use pi over 6 as our reference angle, just like we're doing in this example here. But notice that I can rewrite this, right? 8 pi over 6 is not simplified. That's sine of 4 pi over 3. So you do have to simplify it first. You have to make sure that your fraction is simplified, right? This pi over 6 becomes a pi over 3 whenever we simplify. But besides that, this is the strategy that you use, okay? So you have to make sure that it's simplified, but other than that, this is what you do. With that said, we know that sine of 7 pi over 6 is then going to be positive or negative 1/2. So now the question is simply, which one is it? Well, we have to take a minute and think about where we are in the unit circle, and that will tell us whether sine is positive or negative. So at 7 pi over 6, I sketched this unit circle up here so that we can refer to it in all 3 of these examples. Well, let's see, where does 7 pi over 6 fall? Well, 6 pi over 6, that's just pi, right? 6 pi over 6 is just pi. So that takes us right over here. That's halfway around. So 7 pi over 6, we're going to go just a little bit further. So I'm going to be right here, somewhere here in quadrant 3. And in particular, I noticed that the y value here is negative, right? The y value here is negative. So sine, which is the y value, is going to be negative, right? So we're in quadrant 3, which means that sine of 7 pi over 6 has to be negative. So that tells me that sine of 7 pi over 6 is negative 1/2. Okay. And there you go. Let's move on to tangent of negative pi over 4. So I know that tangent of negative pi over 4 is going to be equal to tangent of pi over 4, or possibly negative tangent pi over 4. That's how reference angles work, right? We're going to look at just regular old pi over 4. We might need to stick a plus or minus in front of our answer. Well, we know that tangent of pi over 4 is 1. So again, the question is simply, at the angle negative pi over 4, is tangent going to be positive or negative? Well, we look here at our circle. We go to the angle negative pi over 4. So because it's negative, we're going to go clockwise. We're going to go in this direction. And pi over 4 is going to take us halfway between that between this point 1, 0 and the point 0, negative 1, right? It's going to take us halfway there, because this entire thing is pi over 2. So pi over 4 is going to be half of that. So we see we're here in quadrant 4. Now with tangent, we have to stop and think for a moment. So tangent is sine divided by cosine. Here, the sine value is negative, right? The y is negative. So we have a negative on top, but we have a positive on the bottom because the x value is positive. The cosine value is positive. So what we conclude is that tangent is going to have a negative over a positive. So tangent is going to be negative here. Okay. So we conclude that tangent of negative pi over 4 is going to be negative 1. Again, we knew right away it had to be positive or negative 1. And then we thought about whether it was going to be positive or negative based on where we were in the unit circle. Finally, we've got cosecant of 19 pi over 3. I intentionally chose a big angle for us here. Well, we know that it's going to be, first of all, this 19 pi over 3, that is simplified. So this is either going to be cosecant of pi over 3 or maybe negative cosecant of pi over 3, depending on whether cosecant is positive or negative. Right? So 19 pi over 3, well, we have to think about it. Remember, the entire unit circle is 2 pi, right? So, and 2 pi, that's the same as 6 pi over 3. So, okay, 6 pi over 3, do another lap, 12 pi over 3. Keep going, we do another lap, we're at 18 pi over 3. And now we need to get to 19 pi over 3. So we just go pi over 3 units more, and that puts us like right here in quadrant 1, where I'm drawing this little line thing. So if we're up here, well, let's think about it. Cosecant is 1 over sine. Sine is positive here because sine is the y value. So cosecant is also going to be positive. So we conclude that cosecant of 19 pi over 3 is going to be positive. It's going to be positive cosecant of pi over 3. Cosecant of 19 pi over 3. Well, let me think. What is cosecant of pi over 3? Well, that's 1 over sine of pi over 3. Sine of pi over 3 is root 3 over 2. So this is going to be 2 over root 3. Which, if you multiply by root 3 over root 3 to rationalize the denominator, you get 2 root 3 over 3. As I said in the last video, your instructor, teacher, professor may or may not care which form you write it in. Some professors or instructors will not want an irrational on the bottom. Others don't really care. Personally, I don't really care that much. But you should be aware of what your instructor wants. In the end, they're mathematically equivalent. So there we go. So that's how we use reference angles. By checking out this denominator, like we said, we do have to make sure that our fraction is reduced, is simplified. So make sure that we do that first. But from there, you're just looking at, is it a pi over 6, a pi over 4, a pi over 3? What is it? And then you have to determine is this trig function going to be positive or negative here based on where you are in the unit circle? So just like that, we can take this table, and by thinking about things, we can extend this to the entire unit circle, which I think is pretty cool. Really reduces them. If you really wanted to, you could memorize all the values for the entire unit circle. I would highly advise it. Anyways, thanks for watching. Hope you found this helpful. In the next and probably final part of this short video series, we will discuss the inverse trig functions, which the trickiest part of those is probably remembering each one of them has a specific range, but we'll get into that in the next video. So thanks for watching. Hope you found it helpful. And remember, watching this video is not a substitute for practice. So take some time, go out and practice finding some reference angles. Anyways, thanks for watching. Hope you found it helpful.